Have you ever just stopped and looked around at, well, everything and wondered what it's all really made of? I mean, not just atoms and molecules, but the absolute, most fundamental ingredients of reality itself. Well, today, we're going to pull back the curtain and look at the actual blueprint of our universe.
You know, it's one of the biggest and oldest questions humanity has ever dared to ask. For thousands of years, it was a question for philosophers to debate. But in the modern age, we decided we wanted more than just a debate. We wanted an answer we could prove.
And to get that proof, we had to go big. I mean, we had to build one of the most ambitious, complex, and honestly, magnificent machines ever conceived by human beings.
We're talking about the one and only Large Hadron Collider, or the LHC for short. Now, the best way to think about it is as the most powerful microscope in human history. But instead of looking at tiny cells, it's designed to peer into the very fabric of existence itself.
The scale of this thing is just mind-blowing. We're talking about a 27-kilometer ring, buried hundreds of feet underground, right on the border between Switzerland and France, at a place called CERN. It is an absolute marvel of engineering.
So how does it work? Well, the process is kind of elegant in its brutality. You take beams of protons, accelerate them to 99.999% the speed of light, and then you smash them into each other. For a fraction of a second, these collisions create a tiny fireball that mimics the conditions of the universe just moments after the Big Bang. And by sifting through the debris, scientists can basically reverse engineer the fundamental rules of reality. It's incredible.
Okay, so you build this incredible machine. What exactly are you looking for? Well, scientists were using it to test a theory, our best guess at the ultimate ingredients list for the entire cosmos.
And that theory is called the Standard Model of Particle Physics. This is it. This is our most rigorously tested blueprint for reality. It describes all the little particles that make up everything you see and all the fundamental forces that tell them how to interact. But, and this is a big but, it's not the full story.
The model sorts everything into two main teams. On one side, you have the matter particles, the stuff that makes up, well, stuff. You've got quarks, which build protons and neutrons, and leptons, like the electron you learned about in school. And on the other side, you have the force-carrying particles, like photons for light, and gluons, which are like the superglue holding atomic nuclei together.
Now, this whole thing wasn't just dreamt up by one person in a lab coat. The Standard Model was this monumental, collaborative effort built over decades by some of the greatest minds in physics. Each one of them added a crucial piece to this giant cosmic puzzle.
For the longest time, the Standard Model was this beautiful, incredibly successful theory. But there was one massive, gaping hole in it. A hole that desperately needed to be filled with actual experimental proof.
I mean, all the math worked out, and all its predictions seemed to be spot on. But without this one key ingredient, the entire beautiful structure could have just come crashing down. So the big question was, is the blueprint actually right?
See, the whole model's integrity depended on finding a particle that was predicted to exist, a particle responsible for giving all those other fundamental particles their mass. Without it, the universe as we know it, it just wouldn't exist. This was the legendary Higgs boson.
And the hunt for this thing took nearly 50 years. Can you imagine? It was first proposed way back in 1964, but we literally had to build the LHC, the most powerful machine of its kind, just to have a shot at finding it. And then, finally, in 2012, history was made.
On July 4th, 2012, the director of CERN stood up in front of the world and said those simple, historic words. They had found it. The final, missing piece of the Standard Model was finally confirmed. It was an absolute triumph for science.
So this is all fascinating, but you might be asking, why does this matter to me? It can feel pretty abstract, right? But the quest to understand the universe at this level has had a direct and massive impact on our everyday lives.
Seriously, this isn't just for textbooks. The incredible technology and the pure knowledge that gets developed for these massive experiments has a funny way of spinning off into applications that change the world in ways nobody could have predicted.
For example, ever used the World Wide Web? Yeah, that web. It was invented at CERN just so scientists could share data more easily. The super powerful magnets made for the LHC, they help make MRI machines in hospitals way better. And those particle beams? They're now a frontline tool in treating cancer. This is research that truly pays dividends for all of us.
But here's the twist. As triumphant as finding the Higgs boson was, it wasn't the end of the story. Not even close. In fact, in a lot of ways, it just highlighted how much more there is left to discover. The blueprint is still very much incomplete. Just look at this.
This chart shows you the profound scale of what we still don't know. Everything the Standard Model describes, every star, every planet, every single one of us, makes up only about 5% of the known universe. The other 95%? It's a complete and total mystery.
And these are the great mysteries that are keeping physicists up at night. What is this invisible dark matter that's holding entire galaxies together? What's this dark energy that's pushing the universe apart faster and faster? And the biggest monster question of all, how in the world does gravity fit into this picture? The Standard Model has no idea.
So, yeah, the quest continues. Deep underground, the Large Hadron Collider is still smashing protons together, pushing the absolute boundaries of what we know. Every single collision is another chance to glimpse something new, to find a crack in our blueprint, and to start writing the next chapter in the story of our universe. The only question is, what are we going to find next?